In this problem, we have to determine force in CF. This member is CF. Since we have to determine force only in one member, we will try to solve this problem using method of sections. First, we will decide how to cut this truss. One way of cutting this truss is this one. Here, three members are getting cut, CD, CF and CE. But all these three members are passing through one point C, and therefore there will be only two equations of equilibrium, sigma fx is equal to 0 and sigma fy is equal to 0. From those two equations, we cannot solve for three unknown quantities, that is force in CD, force in CF and force in CE. So we cannot solve or we cannot determine force in CF in this way. So another way we can cut the truss like this. Again CF is cut, but four members are getting cut in this case. These are CD, CF, EF and BF. Now you can see there is one point F from which three forces or three members are passing, that is CF, EF and BF. So if you take moment about this point, you can determine force in CD, but again you cannot solve for CF. It is not always possible to determine a force by cutting the truss only once. Sometimes we need to cut the truss multiple times. This problem is one such problem. So what we will do, we will cut the truss first in this manner. If you cut the truss in this manner, you can see there are four forces, CD, CF, EF and EB. If you take moment about point C, CD is passing through E, CF is also passing through C, and this EB is also, when you extend, it is also passing through C. So these three forces will become 0. You can determine force in EF. Once you get value of EF, you can cut the truss in this manner, another way of cutting the truss, and here you need value of CF and EF is already determined. So take a point from which these two forces are passing, CD and BF. So if you extend these two are passing through point A. So if you take moment with respect to point A, then force in CD and force in BF will become 0 and EF is already determined. In that case, CF can be calculated. In this case, when we cut the truss in this manner, we will consider right part of the section and therefore we need reaction at point B. For that, we will draw free body diagram of the entire truss. So here there are two supports. This pin support is removed and two reactions are shown, and this roller support is removed, one reaction is shown. You need force in B or RB, and therefore what you will do, you will take moment with respect to point A and equate it to 0, that is sigma MA is equal to 0. Now there are three forces, 2P, P and RB. For 2P, perpendicular distance will be this line, and if you extend this line, and perpendicular distance is from A to here, and this length can be calculated. This total length is 1 and this is a right angle triangle, 90 degree, these two are 45 degrees. So these two sides will be equal. Similarly, these two sides will be equal and these sides will be equal to 1 cos 45. So this length is cos 45. This length is cos 45. This is also cos 45. Once you get this length as cos 45 from this right angle triangle, in this right angle triangle, again this angle is 45 degree, this is 90 degree. So this side is cos 45 into cos 45. Therefore, this length will be 0.5. So this length is 0.5, this length is 0.5, this is 0.5, 0.5, and these lengths EB, EF, DF, AD, these all lengths are equal to cos 45. Let's take moment of 2P. About A, it is clockwise. So 2P into this length is 0.5. And after that, this force P is also clockwise about A. It is clockwise. So positive, and its distance is perpendicular. This one is perpendicular distance. So this is P into 0.5, and RB is anti-clockwise about point A, and its distance from A is 2. So RB into 2. So solve this. So RB into 2 is equal to 1.5p, and divide this, RB is equal to 0.75p. So in this way you are getting value of RB as 0.75p. Now we will cut this truss in this manner. Once you cut this truss, you have to show forces. We will consider upper part of the section and show forces in upper part. So force in CD. I have drawn arrowhead towards the section and thus assuming that force in CD is tension force. So we will assume forces in all members as tension forces. So second one is FCF, again towards the section, FEF, and then FBE. So this is FBE. Now next step is we will take moment with respect to point C. So once you take one sigma MC is equal to 0. So moment of FCD will become 0. It is passing through C. Moment of FCF is also 0. It is passing through C. FBE, again if you extend, it is also passing through C, so its moment is also 0. So there are only two forces remaining, FEF clockwise and P anti-clockwise. So these two forces we have to determine moments. So moment about point C. So these forces, so you can take these distances. For P, this is perpendicular distance. Again, this distance is 0.5. This is total 1. So this distance was 0.5. We have already determined. So this is also 0.5. For P, perpendicular distance is 0.5. For FEF, this is 90 degrees. So CE is the perpendicular distance, and this distance is equal to cos 45. So this distance is cos. This length is 1. This angle is 45. This is 90. So this will be 1 cos 45. So put these values. So FEF into 1 cos 45 clockwise, and P is anti-clockwise. So minus P into 0.5 is equal to 0. Solving this, you will get FEF as equal to 0.71 P. So FEF we have determined. Now in next step, we will cut section in this manner. Now FEF is determined. You need FCF. To get FCF, what we will do, we will take moment about a point from where these two forces CD and BF are passing. So these two extended are passing through point A. So determine sigma MA is equal to 0. First take right part of this section and show forces. So this is FCD, this is FCF, FEF, this we have already determined equal to 0.71 P, and then FBF. Now take moment about point A and equate it to 0. For taking moment, we can see that FCD, its moment will be 0, and FBF, its moment is also 0. So we have to take moments of forces FCF, FEF, P and 0.75 P. So there are 4 forces. For FCF, perpendicular distance is AF, which is equal to 1. For FEF, extend this force and draw perpendicular. So this length, and this length is nothing but DF, and DF is equal to cos 45. We have already determined these lengths are cos 45. So for FEF, perpendicular distance is cos 45. And for P, perpendicular distance, extend this P and draw perpendicular from A. So this length is same as this length or this length. This is equal to 0.5. And for 0.75 P, perpendicular distance is 2. So in this way, you can calculate sigma MA is equal to 0. So sigma MA equal to 0. FCF, this is FCF into this distance 1. P is clockwise, FCF is also clockwise, so positive. P is also clockwise about A, so positive, and perpendicular distance is 0.5. FEF, this length, so perpendicular distance is cos 45. Again, this is clockwise, so positive. Only anti-clockwise force is RB, 0.75 P, and its distance is 2. So is equal to 0. Now solve this. Now value of FCF is known. No, we have a value of FEF is known, 0.71 P. Put that value here. And after that, calculate. So FCF is there. and this is 0.5p, this is 0.71 into cos 45, so again you are getting 0.5p, and 2 into 0.75, 1.5p. So once you solve this, you will get FCF as 0.5p. This is the required answer. Now there is another way you can determine, which I feel easier than this. What we will do in second case, first we will cut the section in this manner. Already we have determined this reaction, and taking moment about F. So show forces. I have shown all these forces and considering right part of the section. So take moment about F and determine FCD. So what I have done, sigma MF is equal to 0. So moment of FCF, FEF and FBF will be 0. You have to calculate moment of FCD, P and RB. So these values are, so FCD is anti-clockwise about F. So F into perpendicular distance is FD cos 45. Then this is anti-clockwise 0.75p anti-clockwise, and its distance from F is 1. So this one is into 1. And third one is this P about F, it is clockwise and its perpendicular distance is 0.5. And solve this, you will get FCD as minus 0.335p. So once you get FCD, you can cut section in this manner, and here you can apply, we have two equations, sigma fx equal to 0 and sigma fy equal to 0. So show all these forces, FCD, FCF and FCE. I am considering upper part of the section so that only these three forces will be there. So draw these three forces at one point, FCD at an angle of 45 degree, FCE again at an angle of 45 degree, and FCF vertical downward. Now apply sigma fx equal to 0. What you will get? FCD is equal to FCE. So these two values are same, minus 0.35p. Now apply sigma fy is equal to 0. So fy, when you apply this one, so FCD cos 45, FCE cos 45 and FCF, all these three are in same direction. So same sign I have used, FCD cos 45, FCE cos 45 plus FCF is equal to 0. So FCF is equal to 2 times FCE and FCD are same. So I am replaced FCE by FCD. So minus 2 into FCD cos 45. Now value of FCD is minus 0.35p. Put that value here. So minus 0.35. So minus minus will cancel each other. And when you solve this, you are getting 0.5p. So force in CF is 0.5p. Positive value shows that this member is tension member. So in both cases, you are getting same answer, 0.5p. Thank you for watching this video.